So the next one we will learn, we talk about is a Z table. And so what is a Z distribution? What is a Z distribution? Yes. We're going to learn several distributions in this class, and Z distribution is going to be probably end up to be our most favorite. The reason is because it's going to be the simplest one, right? Okay, that's the easiest one. Okay, so what is a Z distribution? How would you describe the shape of it?
Is that the one with the bell curve?
Yes, right? Exactly, Rachel, right? Okay, so bell curve. Right, okay, so this is on the left, that's not a Z distribution, a bell curve. We're gonna learn two different bell curves for this class, and Z distribution is the first set. And the next set distribution we're gonna talk about is known as a T distribution, which we're gonna talk about, I think, in week 3, Okay, so Z table is a bell curve. It's also known as a normal distribution. Actually, I want to be more specific here, okay. Z here, okay, is not any normal distribution. What kind of distribution it is? There's a word in front of normal. What is it called? It's not any normal distribution. What is it called? It's the standard normal distribution, right? Okay, I'm gonna write down here. So Z, actually, it is the standard normal distribution. So what does it exactly mean, standard normal distribution? Because whenever we talk about normal distribution, you need 2 sets of numbers. So you can see me leaving 2 space here. So the first one, you need the mean to describe your normal. That means you have to tell me where is the center of this distribution. And what is the other thing you need when you describe a bell curve or normal distribution? What else do you need? You need a median, a mode, a range, a variance, a standard deviation. Which one? Standard deviation, right? Okay, very good. Standard. So you need a mean and a standard deviation. So Z, normal distribution, it means when the mean it is 0. Okay, so standard normal means when the mean is 0 and the standard deviation is 1. So you can clearly see you can change mean and standard deviations to other numbers that's going to hold as well. But they are not our standard normal distribution. Standard normal distribution means the mean is always 0 and the standard deviation is always 1. Okay, so whenever we talk about distribution, we want to learn how we can find out the probabilities. You probably heard about that from the slides, using Z tables, right? Okay, so hopefully you guys all have a copy of the Z table. Okay, so let's see, a copy of the Z table. Okay, clear it. Okay, great. So this is a Z table here. So several things I want to emphasize. I think you guys have already probably heard it from my videos already. So this is the first set of a table. You guys are going to learn how to read it. This is known as a Z table or standard normal table. Okay, we are also going to learn about T table later on. So there are 2 sets of numbers. Very, very important. You know, there are so many numbers, but they can divide it into 2 groups and nothing else, just 2. So the first set of numbers, it represents the z-scores. Okay, and the numbers in the middle, right? The numbers in the middle, the shaded one represents the probabilities. Probabilities means the area under the curve, Okay, so several things I want to remind you. Okay, so the probabilities, whenever we talk about probabilities, okay, so let's see. I need, well, I need a little bit space. Okay, so I'm gonna use this one. There's more space here on this slide. Okay, so let's do animation. Okay, I need a drawing. Okay, so whenever we talk about bell curve, okay, what is the total area under the curve? Yes. Total probability under this bell curve. It could be normal, it could be a standard normal. What is the total area under it? 2, 1, 100%, 0. It is 1, right? I'm sure some of you are thinking, okay, so the total area under this curve is 100%, right? Okay, So that's why it's very, very important that you know whenever you talk about probabilities, that means the numbers in the middle here, they have to be between 0 and 100% because probabilities, right? We're talking about probabilities. So probabilities cannot go beyond 100%. So those numbers, okay. So two sets of numbers, very, very important, very, very important. This is the questions, okay. So we're gonna work on this exercise together and hopefully that's gonna be, okay, so the very first one, A, probably Z more than 0.34. Have you already solved that one? Are you able to get it? Okay. So okay. So I guess I'm gonna show you how this can be done. Okay. So it is. I know this is very, very important. I couldn't stress it more than enough. Okay. Every time, every time you work on this kind of problem, very, very important. You draw a bell curve. You know, if we are taking this class in a face-to-face setting, you guys are going to draw this with me on a piece of paper, and by the end of the term, everyone becomes the expert in drawing bell curves. It's very, very, very important, extremely important. Okay. Whenever you work on quizzes, assignments, English assignments, be sure that you have a bell curve being drawn. Okay, I had students in the past who asked me, can I reuse my bell curve? No, absolutely not. You want to redraw a new bell curve for every single part of the question. For A, you're going to have a brand new bell curve with just 2 lines. I can't believe you guys are so lazy that you want to reuse it. Okay, so let's get back to the question. Okay, so draw a bell curve and you take a look at the question. So this is about a Z distribution. So as I said before, Z is a mean 0, standard deviation 1. Right? Okay, so terrible drawing. Okay, so over here, what is the center right here? It's 0, right? Just say it is mean 0. So this is 0. Whereas the 1 is very, very difficult to label. We are not going to do that. Okay, so let's see what we want to do here. So they are saying you want to find a Z which is more than 0.34. Okay, so I'm going to ask you a question. So the 0.34. Is this a z-score or is this a probability? We just discussed there are 2 sets of numbers, a z-score versus a probability. So is this a z-score or is a probability? A z-score, right? This is not a probability. A probability, actually, it is this one. This is the probability. The entire thing is a probability, whereas the 0.034, this is actually a z-score. Right, okay, so let's try to figure out how to do that. Okay, so here, 0.034, I'm going to label it out, 0.34. Okay, so we want to find a probability to the right of it. So you want to draw a line. So this is the part you want to find, right? Okay, so what are you going to do next? You're going to look up the z-table, right? You're going to look up the z-table. Okay, so you have the z-score. You want to find its corresponding probability. Are you going to look up for 0.34? 0.34 then? Yes, right. We are all going to look it up. Okay, so let's see. Okay, 0.34. Okay, so let's do that. Sorry. 0.34 is here. And you can see how I read it. Okay, so this is 0.34. And so it's right here. So 0.6331. Is that a final answer then? Okay. So would you say that's the final answer?
No.
I heard someone say no. Okay. Why isn't?
Because it's saying Z is greater than that value, so it's
to the right, right?
Yeah.
Okay. Okay, so this is absolutely right. So instead of doing having the answer to be 0.6331, instead it should be 1 minus that, right? Okay, so it's going to be 1 minus that. That's going to be 0.3669. Okay, so is this part clear? I mean, feel free to stop me. And so the next one, this one is easy because you can see it is less than negative 0.71. So this is already to the left. You can read up your table right away. There's one thing I put this example here is because you can see this is a z-score. Okay, so this is a z-score. But this z-score is accurate up to 4 decimals, 4 decimals. If you look carefully of the z-table, which I just showed you, the z-scores over there are only up to 2. So whenever you want to use this z-table for anything that's beyond 2 decimals, what you're gonna do is you want to round it to 2 decimals. That's going to be negative 0.71, right? So this is what you want to do. And so the answer, you can look up your answer. You can check it with mine. That's going to be this one. Okay. So what's going to be slightly more difficult is this one. And we're going to work on this. Maybe some of you were already able to do that. So let's try. So this is going to be a bell curve. Okay, 0. Okay, because it's a Z, right? You guys see it? It's a Z. So Z is a standard normal distribution which has a mean 0. Okay, so there are 2 numbers here and they are all Z-score. I'm gonna write down here 1.98. And over here, I'm gonna just draw it slightly to the scale, not too far away because this is only less than half, 0.49. Great. Okay, so what we are finding here is going to be a probability less than 0.49, but more than that. If you look carefully, that's going to be anything in between. You guys see it? And so you're finding a probability. Remember, probability means the area under this bell curve corresponding to this part which I just drawn. So you're going to just draw it here. And so you were asked to find this part, right? Okay, so how are you gonna find this one? This is not that straightforward. Previously it was completely to the left or maybe completely to the right. So you can use the table once, right? Over here you have 2 numbers and you are talking about in between. How are you gonna solve it? Okay. So you would have to do it twice, okay? If you watch the video, you know it. So you do it twice. The first thing we're gonna do is, okay, so what you're gonna do is, okay, so let's see. Well, you're gonna find the total area to the left of a 0.49. So that's gonna be this part. You're gonna find the total area to the left of a 0.49. But you were like, this is not what we want. We want to find the area in the middle. But you found this part which shouldn't be there. So what you're gonna do is you're gonna use the total area to the left of 0.49 and minus subtract the area to the left of a negative 1.98. Because if you do that, it's gonna remove this part and that's gonna give you the middle part, right? So that means, okay, so I'm gonna say again. So first, you're gonna find the area to the left of a 0.49. You're gonna write it down the number. Okay, so if you did that, I think, okay, so let's see. I think you're able to find it. Okay, so, and you're gonna find it again using the Z table, the area to the left of a negative 1.98. And their difference, those 2 probabilities, is gonna give us the probability of the area in the middle. Okay, so let's see. So you should be able to see it. Yes, so you can see 2 probabilities, right? The first one corresponds to area to the left of that. And then the second one corresponds to the probability of a minus 1.98. You're gonna do a subtraction, you find the area in the middle. So whenever we talk about the probability between something, for example, I was like, I want to figure out what is the probability of a college students, between the age of say 20 and 22. So that means you have to find what is the total percentage of students who are less than 22. And then you're gonna find a percentage of students who are less than age of 20. And then you're gonna minus those 2 probabilities, right? Okay. And so the first ABC is fairly similar to each other. And so we're gonna move on to the next set of exercises. It says the area to the left of a Z is 0.9767. The area to the left of a Z is 0.9767. Okay, so you want to ask yourself, what is this 0.9767? Is it a probability or is gonna be a Z-score? Okay, so that means it says area to the left, right? Is it a probability or is it a Z-score? You don't know what a Z is. You were given the probability. So this is clearly a probability. So if this is a probability, you want to be sure you're looking for a probability that's being 0.9767 from your Z table, right? Okay, so let's try. I'm looking for 0.9767. So the probability refers to those numbers in between here. I'm looking for 0.9767. Okay, so there's no easy way out. You have to look for it. Fine, I'm gonna zoom in so make sure everyone can see it well. Well, you know, maybe not so big. Okay, great. 0.9767. 9767. Yes, here, right? You guys see it? Okay, so you would have to find its corresponding z-score, which is 1.99. Right? Do you guys see it here? 1.99 has a corresponding z-score, corresponding probability of 0.9767. And this is the area less than 1.99. That means on average, there's about 97 or 96% or 98% of observation, which is less to the left of a 1.99 standard deviation, which corresponds almost to 2. That means on average, almost 97, 98% of observation is going to be less than 2 standard deviation. So 2, even though it's a fairly small number, it's only 2, but majority of observation is actually less than it, 0.98, right? If you have already watched the empirical rule slides, you probably remember what I said there. Most of observations are going to be between 3 standard deviations. So 2 standard deviation is also fairly big, and that's why 97, 98% of observation is going to be within that. Let's see, I'm going to go back to the questions we were working on. Great. I think you guys, okay, are you, okay, you guys are probably seeing. Okay, great. I'm getting better to this one. Okay, so you can check out the answer. If you color it using the this one, you can see it is 1.99. Okay, so you should also be able to figure out how to solve this one. This is also straightforward, fairly straightforward. Number is 0.1210, so let's try 1210. Okay, so I'm looking for a fairly small one. 1210, 1210. Okay, it's right here, right? So you can find its corresponding z-score, which is negative 1.17, right? 1.17. Great. Okay. So one thing you probably have to pay attention to is, I think the question says is to the, I think the question was saying is to the right of it, to the right of it. So you probably have to use 1, subtract this number, and then you're gonna look for the probability. Okay, 1.17. 1.17. Okay, okay, good. And so this one, let's see. Okay, okay. So the area between 0 and z is 0.3289. So I'm just quickly show you how I can draw this one. Z table, make sure you have a bell curve, make sure you have a fresh one here. So this is a 0. And we know that a z is positive. So z, if it's a positive, that's going to be on the right-hand side. I don't know exactly where z is. I'm just going to draw here. Okay, so we know the area in between of them is about 30%, 32. So this is the middle part is 0.3289. Great. So how would you figure out a z? Okay, so first thing, as always, you want to ask yourself, 3289. Is this a z-score? Is a probability? We were talking about the area. So this is clearly a probability. And do you want to look up for the 0.3289 from your z-table right away? Do you want to look for 0.3289 from the z-table? You probably don't want to do that. The reason is because this is the area in the middle, not completely to the left, not completely to the right. You want to change this one to something completely to the left or to the right. Okay, so what you can do is, you were like, this is a 0.3289. What is the area to the left of 0 then? What is this, the white part? What is about the white part? Is it 1? 50%? 20%?
Is it 50?
Half, right? Jackson is right, 50%, right. So the white area is 50%. You know this part is about 32, 33%. So you want to add up those two numbers. And that's going to give you 0.8289. 8289. I definitely need I probably need an iPad. I think, you know, I will try to ask this IT support to make sure I get an iPad for this. Okay, 0.8289. Okay, so this is the probability you want to look for from your table. And so let's do that. Hopefully you guys are able to see my screen. Okay, so 8289. So this is what you want to look for. Okay, so let's see. So 8289. And you're gonna look for 8289. Yes, this one. So it's a 0.95. You guys see it?
I actually can't see
Yes.
it anymore.
0.8289. We were looking for this probability. You see it's 0.95. You guys see it? 0.95. So for that particular question, what is a z? Z is going to be 0.95, right?
How did you come to 0.8289?
Okay, good question, good question. Okay, so let's, let's see. So it was 3289, remember? And we add a 50%, 0.5 to it. So that becomes 0.8289, right? Okay, is it clear? Okay, okay. So you can also check my answer here by, okay, one tricky question here. How about if the area between 0 and z is positive, is 0.6250? What do you think is the z? Right, a new bell curve, a zero, a z. So what we know that the area between those two is 0.6250. What is a z?
You just subtract 6.6250 from 1 from the 100%.
Okay, so if we do that, okay, so if we subtract, okay, so let's see. Great. I need to, so that was Jackson, right? Jackson, okay, good. And so let's see. So the question told us the area between those two is 0.6250. Okay, and if we do subtract from 1, that means this part and this small corner, it's going to give you whatever the difference between this number and 1. So I think that's going to be 0.3. Okay, so let me. So if you use 1, okay, 1 minus 0.6250, that's going to give you 0.3750, right? Okay, so that means this part and this part is 0.3750. Does it look any suspicious to you? Anything going wrong here? What do we talk about the area to the left of 0? What is the area to the left of 0?
50%.
50%, yes. If this part is 50% and you add up another small corner, I don't know exactly what the area is. 50% plus something which is positive, because whenever we talk about probability, we talk about area. The area has to be real, right? We are not talking about anything that's imaginary for this class. 50% plus a positive number. How can you get a 37% afterwards? So there's something wrong with it. This is actually not possible, because the total area between 0 and z, as long as, for any z, the area between 0 and z, it cannot possibly be 0.6250. It's not possible, because the area between 0 and z has to be less than 50%. It has to be less than 50%. Right? Not possible. Does it make sense? I was trying to trick you guys, trying to make sure you guys actually are thinking along with me, because it is not possible for the area between 0 and z is more than 50%. Because whenever you have a z-score which is 0, that means you are talking about the observation which is higher than the average. So there should be 50% of the observation, at most 50% of the observation, between a z-score of 0 and any other z-score, at most 50%. And now you tell me it's actually 62.5%. That's not possible, because there's always 50% of observation that's less than z, less than the average.
Is 0.625 a probability?
Yes, yes.
Thank you.
Yes, just like here. Okay, so I'm gonna clear out of this. Hopefully you guys have already drawn that. Okay, so clear out my drawing. Yes. Okay, so the area between 0 and z, so this is the probability, and this is also the probability, right? How do I know whether it's a probability? if they were talking about z-score, if they were talking about area probability, that means there's a probability. If it just gives you right here and you are comparing that number with a z notion, the z symbol here, that means this is a z-score. This is the z-score, right? Okay, z-score just means, as I said at the beginning of this session, that means how many standard deviation above or below the average you are. And for this particular question, the part G, which we just covered here, okay, I don't know what a Z is, but I was like, I know that the area between the average, which is a 0 here, and another Z score, which I don't know what the number is actually 62.5%. And that's not going to happen because you know that the area between 0, under 0, less than 0 is already 50%. How can you have another 62%? If you do 50% plus 62%, that's already over 100. That's not possible. The total area under the curve, the largest you can go is going to be 100%. Right? Not possible. Great. Any other questions I have from you guys? Feel free to chat me as well, right? Okay. Okay, good, good.